This week on Quality Digest Live, we talk to Richard Devaney, author of The Pan-Industrial Revolution, How New Manufacturing Titans Will Transform the World. Do you think that 3D printing can't rival traditional high-volume manufacturing methods? Well, you might be surprised when we come back. Welcome back to Quality Digest Live for February 8th, 2019. QDL is your weekly look at who and what is making news in our industry. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest. Well, all of us in our industry are familiar with industrial 3D printing. We are seeing more and more production parts coming out of 3D printers in a wide variety of materials and sizes. You may have gotten a 3D printed dental implant or maybe a hip replacement. You might have been at the 2014 IMTS show in Chicago and seen the collaboration of AMT, Local Motors, Oak Ridge Labs, and Cincinnati Inc., where they printed and assembled an electric car. So you've seen the technology, you know how it works, but many still question whether 3D printing will take over traditional mass production manufacturing methods, or maybe it's just going to stay the tool of choice for short-run, low-volume, or custom parts. Well, our guest today is Richard Devaney, author of The Pan-Industrial Revolution, How New Manufacturing Titans Will Transform the World, and he believes that 3D printing is going to completely change manufacturing as we know it, and that the change is already happening. Hi, Richard. Thanks for joining us today.
Oh, thank you, Dirk. I'm very glad to be here.
Well, terrific. Well, I got to say, it was a really interesting book. You covered a lot of material in there, and I'd love to be able to touch on everything that you dealt with in there. But first of all, let's talk about the title. You call it the Pan-Industrial Revolution, and your contention, and you even say in the book, it's not without it's not that you don't have naysayers, is that additive manufacturing or 3D printing is going to completely change manufacturing as we know it, and that change is actually happening right now. So, kind of gives us a synopsis of what you're talking about in that book.
Sure. The Pan-Industrial revolution comes from the idea that markets are going to merge together, so that the same company one day makes bicycle parts, the next day it makes automobile parts, the next day it makes automobiles, the day after that it makes some other metal parts, and so the factories start to merge together, all sorts of different products, and as a consequence of that, the capability of merging all sorts of different products is coming to fruition here. And additive manufacturing is speeding up that process because of its incredible flexibility and the rate of development in new kinds of design methods.
Okay, and let's talk about that a little bit. You just kind of touched on it a little bit here. What I think you're going to call economies of scope. But before we get to that, let's talk about just plain old mass production. And when we talk about mass production, obviously there's economies of scale. The more parts you can make with one setup in a shorter period of time, the cheaper it is per part. And that's always kind of been the argument against 3D printing, is like, well, they'll never be able to match the kind of, output that you get from traditional mass production techniques. And because of that, the cost per part is never really going to be feasible for mass production. So how would you address that? Well,
I think the people who are saying that don't understand the full impact of what additive manufacturing allows. So let me give you a couple of examples where mass production of things can take place because of the special properties of AM. The first is an example in making OLED screens. Companies like LG and Samsung have spent a lot of money with smaller firms like Cativa to develop an entirely new way of making the OLED screens. And in conventional manufacturing, what happened was a thin plastic mask was put down, and then they they sprayed across the top, and where the mask didn't exist, some of the spray went through and remained onto the display. But now with additive manufacturing, you don't need these masks. You just have tiny little inkjet printers, which put down the drops of these very expensive materials only in the places you need. So it eliminates a tremendous amount of waste. And as a consequence of that, it goes to the point where the costs are about 30 to 40% below conventional manufacturing because of the reduction of waste.
Oh, so if I can interrupt for a little bit. So that's interesting. I hadn't thought about that. So there the savings is coming across from less wasted material. You're only putting down the material that you need, not spraying 90% of it over a mask that's then going to be discarded.
Correct.
Oh, interesting.
Correct.
Okay.
Now another. I'm sorry. Go ahead.
No, go ahead. I'm sorry.
Another way that this becomes cost competitive is by the elimination of assembly. It's kind of the exact opposite. Rather than trying to make very simple parts and then assemble them all on one long line, what's kind of called the Fordist Method, based on Henry Ford's assembly line process, that's going to disappear because 3D printing allows you, for example, to combine parts or to insert parts during the production of the overall piece of equipment that eliminates assembly. So, for example, let's say you're building a cell phone. You can, while you're laying down the plastic outer case or structure of the cell phone, you can also lay down conductive traces, which act as wires, and circuitry on the interior of the walls of the cell phone. And as a consequence, there's no more, you buy the electronics made in one place and then you stuff it into the cavities of the plastic container made by a completely different company. Now both happen together at the same time, and there's no assembly charge. So you get rid of lots of people. And that allows for manufacturing to be done in many places where it couldn't be done before.
Well, and talk about manufacturing in other places. Another thing that I think you touch on your book, which I think a lot of people don't think about, is traditionally what we have is maybe a couple of really large, let's say company, Acme Corporation has a couple of really large factories that are cranking out, jillions of parts from some central location in the Midwest. And I think one of your arguments was that, well, we don't really need to do that anymore. You can have distributed manufacturing where you're making smaller numbers of parts, but you're making them near where they're needed. So you decrease your distribution cost and you're distributing your manufacturing over a lot larger area.
Yes, that's correct. And that cuts out all kinds of transportation costs, damages, shipping costs, keeps down your inventory levels. So inventory carrying costs disappear. And when you look at the full system of costs that you create around manufacturing, a lot go away when you start talking about 3D printing the products on a distributed manufacturing program. And there are several companies who are planning the build out where, for example, they would produce a small number of things, let's say cars, and Local Motors was going to print out, rather build 50 factories in the United States. Some states wouldn't get any, and some would get 2 or 3, depending on the number of cities that were in those states. And they would locate them, and each factory would make about 2,400 cars a year, and that's it. But it got rid of a whole bunch of excessive costs, and it lowered the break-even point of the company. So because it's less capital intense with these like mini factories, and all of that together led to a much cheaper thing. Since then, Local Motors has stumbled onto an even more lucrative market and decided to refocus, and that is to make specialty vehicles like the Ollie, which is a self-driving autonomous minibus, and people are buying them at 400 at a time. Places like Disney to be used in its parks. They transport people around, and they just run on their own, and you jump off and on them. Las Vegas is buying some to run up and down the strip, so you can get from one casino to another without the long walks. Some cities are thinking about doing it, and so this is a tremendously big opportunity that they can generate cash from right away, compared to the car business, where basically they have to wait for a ton of certifications and government approvals and so forth. So you get the idea that you can create all kinds of new products also in these 3D printing operations.
And let's switch gears a little bit from let's say the number of parts you can produce, or distributed manufacturing. You bring up an interesting topic also, what you call economies of scope, what I call you can build anything you want anywhere, which is kind of you're not basically economies of scope, and correct me if I'm wrong, is you're saying manufacturers aren't locked in to building a particular type of product or breed of product. I just make, I just manufacture, angular parts, door frames. I just make door frames. You're not locked into that anymore.
Yes, that's correct. Although there are limitations to every technology right now. You can't make bathtubs and microbes out of the same equipment, or heart tissue. So there are some limits, but those limits are much broader than you'd see in current manufacturing processes, and a lot more seamless. So let's just take a look at running shoes. All the major running shoes companies are moving towards 3D printing of the midsole. It's a complex design of a midsole, and they have to make a left shoe and a right shoe, and then they have to make them in hundreds of different sizes, and so this leads to an incredible amount of complexity. And then you've got running shoes and tennis shoes and so forth and so on, and it adds up to millions and millions of different things that have to be made. And before, you'd have to develop traditional, injection molds, which had limitations on how good the matrix could be inside the midsole, meaning the sponginess is going to be limited. And now you can, basically, with 3D printing, mass produce these items simply by putting into the machine an electronic file. And then beyond that, now where else can you use plastic matrices? Any place else where there are walls that can be hollowed out with a matrix to be lightweighted, or equipment that you want to reduce the amount of material used in, this same technology can be used. So instead of just being a shoe manufacturer, you can make millions of shoes of different types, and you can make millions of products of different type that use the same plastic technology.
So if we talk about vertical integration, so as kind of to carry the sports shoe example on, you could be making not just sports shoes, but you could be making other types of sports equipment that might use the same materials, need the same requirements. So you wouldn't be just a shoe manufacturer. You could be making other sports related equipment. And so basically working a vertical market, essentially.
Yeah. And the key factor, though, is, I mean, we have companies today that do that, but they do them in different factories. And with additive manufacturing, you can do all of those same products with using the same equipment in the same factory. And the consequence of that is you get what I call economies of scope, because the more products you add to that, the more you keep your factory busy. And capacity utilization is an important element of manufacturing costs. In addition to that, you can get a lot more consistency. If one product affects another one, then you can make all the changes at once, and you can do it on the fly. You can pool together. Another piece of this is that all these products now being made by one company, they can get pooled purchasing and pooled distribution for this multitude of products. So it's not just manufacturing economies of scope, but all the adjacent functions around it, supporting functions, now can take advantage of that economy of scope. Whereas before, basically you had to build a conglomerate with, you just owned 5 different businesses and ran them as 5 different operations with 5 different sets of equipment. And now one set of equipment, one operation, and a lot of vertical integration simplifies the supply chain as well.
And last question I want to get into here. You do say, I mean, the subtitle of your book, The Pan-Industrial Revolution, is How New Manufacturing Titans Will Transform the World. So my last question to you here is, in your title, your subtitle, you seem to be saying that this revolution, this huge change in how we envision manufacturing is being led by, Fortune 500 companies. But you also say in your book that it's really the startups and the young companies that are kind of embracing additive manufacturing, 3D printing and so forth. So who is it? Who is going to be not the vanguard, but who is going to be the big movers and shakers that are really going to shake up the world and move this technology forward in ways that we haven't seen?
Yeah, I've seen some hints out in the marketplace. Of course, the small players are going to be innovators, but I think if you have a big player, it's likely to buy up the small players once they reach a certain size and have demonstrated the concept so that they can use it in-house. Classic example of this would be General Electric, where they're building a division called GE Additive, and they've done it through a set of acquisitions, starting from the first one, which was Morris Technologies, and then they recently have purchased a couple of other companies, all that work with high-end, high-temperature metals, and they kind of dominate that marketplace. There's lots of little players that could be there making 1 or 2 of this and 1 or 2 of that, but eventually the learning curve of the technology, of the metals, and of the consulting breadth and service that you can provide will allow the bigger players to get bigger and the smaller players to just become acquisition targets as part of their, exit plans as they build the organization. And when you deal with all these economies of scope that we were just talking about, the bigger you are, the more advantage you have. And as a consequence of that economy of scope, the bigger firms are favored in that process. So at the end of the day, I think what we thought of as makers is just they're not gonna survive. And the startups are gonna be targeting to be sold out to companies.
So they'll have the bright ideas and the ways to implement them, and then the big companies, as usually the case, will buy them up.
Right. This is not like groundbreaking expectations.
Right.
Intel has a group that does venture capital. And they go out and buy them and then absorb them. Cisco does the same thing. There's lots of companies that are out there constantly on the prowl for small companies, which they can suddenly take that technology and spread it out over thousands of products, and the technology becomes much more valuable when you're using it with thousands of products and thousands of different kinds of customers than that little company can, who just started up a year or two ago.
Right. Well, Richard, I've got to say you covered a lot of material in your book. There's something in your book for everyone, whether you're familiar with additive manufacturing, 3D printing, or whether you're a newcomer to it. I recommend it for any of you who are interested in the topic. You cover everything from kind of traditional 3D printing that a lot of us know of to some really interesting technologies that a lot of you may not even have heard of that is going on in industrial 3D printing. So Richard Devaney, author of The Pan-Industrial Revolution, How New Manufacturing Titans Will Transform the World. Thanks for joining me.
Well, thank you very much, Dick. This was a lot of fun.
Oh, well, good. So that is it for today's Quality Digest Live. Thanks again to Richard Devaney for joining us. And don't forget to check out his book, The Pan-Industrial Revolution, How New Manufacturing Titans Will Transform the World. It's available on Amazon. I just saw it there. So. And as usual, just a reminder to all of you, if you have some ideas of who or what you would like to see on the show, send them to us at qdl@qualitydigest.com, and we'll try to bring those people or those things onto the show. So thanks for joining us today, and we will see you next week. So long.